So today we will see functions of operating system. Some of the common operating system components are process management, main memory management, file management, input output system management, secondary storage management, networking, protection system, and providing interface for the command interpreter. And these are also called the function of the operating system. So let us look at each one of them, starting with process management. So what is a process? A process is nothing but a program in execution. So what is a program? A program is a passive entity, whereas a process is an active entity. That means any program that is stored in the computer, when you double click on that, for example a media player, when you double click on the media player icon, the media player is loaded by the operating system from the hard disk to the main memory. So in the hard disk it remains as a passive entity. When it is loaded in the main memory, it becomes an active entity, and this is what we called as an process. Some of the example of process are: a compiler is a process, a word processing program like Notepad, MS Word, a program to send output to a printer is also a process. A process needs certain resources including CPU time, memory, files, and input-output devices to accomplish its task. For example, if you consider the media player, it will need the CPU for some amount of time for which it needs to run. So that is the resource CPU time. Also, it must be allocated some part in the main memory. So that is also your resources. Also, your media player will be accessing the files stored in the hard disk, so this is also, the files is also one of the resource. And the hard disk itself is the input output device, so the process also needs to access the hard disk. So these are certain resources which are required by an process. So in and all, we can say that for the media player it needs the CPU, the time of the CPU, it must be allocated memory in the main memory, it needs to access the songs which are the files, and it needs to access the songs which are in the hard disk, which are input output device, to run a particular song. And the operating system is responsible for the following activities in connection with process management: scheduling processes and threads on the CPU. So there can be several processes running in the system. So which process should run first, which process should run second, the order in which the processes should be executed is decided by the process management component of the operating system. Also, along with process, the same concept applies to the threads also. Now what is a thread? A thread is a single sequential flow of control within a program. The real excitement surrounding threads is not about single sequential thread, but rather the use of multiple threads at the same time. So more on threads we will see in the coming chapter. So as of now, you can just understand that this is a single sequential flow of control within a program. Coming to the next activity is process creation and deletion. So whenever the program is loaded into memory, a process is created, and when the process finishes its execution, it is deleted. Next is process suspension and resumption. So if there is an interrupt, as you might have studied about interrupt in computer organization and architecture, there can be some form of interrupt to the process. So the process will not be able to continue, it will be suspended for some time, and after some time, when the interrupt has completed, then it will control transfers back to the process, and the process resumes its execution. So process synchronization is about utilizing the resources by multiple processes in such a manner that the system remains consistent. There is no conflict. For example, two faculty members going to the same class at the same time will result in a conflict. So a routine is being made which helps in synchronization between the two faculty members. So they check the routine and accordingly they go to the class. Maybe first period, first teacher, second period, second teacher. The similar way, any resource, whether that be memory, whether that be CPU, as there are multiple processes running in the system, there must be some form of synchronization between the processes so that the resources, in this case maybe CPU or memory, is utilized in an efficient manner. Coming to communication, so generally processes communicate with each other to solve a task. So that communication can be either in the form of shared memory, as in the case of a multiprocessor system, or a message passing system. So we'll discuss more on this shared memory and message passing system in the coming chapter. So next is main memory management. So the operating system is responsible for the following activities in connection with memory management. So here we are talking about main memory. To keep track of which parts of the memory are currently being used and by whom. Next, decide which processes to load when memory space becomes available. Third, allocate and deallocate. Third, allocate and deallocate memory space as needed. So for this, let us look at this particular example. So there are three figures, A, B and C, and if you see the first figure A, you can notice a part is reserved by the operating system and there are four processes, P1, P2, P3, P4. So the first job of the operating system memory management module is that to allocate each of the processes a part in the memory and also keep a track of which process is in which part. For example, initially when P1 is loaded and the operating system is loaded and a new process P2 comes in, it should be ensured that P2 is not copied in this particular section or in this particular section. So that overlapping must not be there. Similarly, when P3 comes in, operating system has already the information about P1, P2 and the operating system itself. So P3 will be given a free space. And similarly it happens with P4, and rest of the part will be the empty space in the main memory. So this is step 1. So you can see all the processes are of different size, 2 MB, 7 MB, 1 MB, 5 MB. So when a process completes its execution, the responsibility of the operating system is to release the memory. So in this case, suppose P2 has completed its execution, so the memory is deallocated from P2. So in this case you can see the empty space as it has been deallocated. Now this free space and this free space are available. One of them size is 1 MB and other size is 7 MB. So suppose a new process comes in, P5, and whose size is 5 MB. So this new process needs a free space. So operating system is already having the list of free spaces. So one of the free space is this, another free space is this in the figure B. And it is observed that this free space of 7 MB is big enough to store the process P5 of size 5 MB. So the process P5 of size 5 MB is stored in this particular space and the leftover space is again empty, and the remaining is empty in figure C. So if we see in this example, one is allocate, deallocate is one of the function. Second, to keep track of which process is in which part of the memory, and to see that when the memory space is available, as in this example P5, it will be loaded in which of the empty space. So that is the three activity: allocate, deallocate, tracking up to which point the process is allocated, and whenever a free space is available, the process should be occupying which of the empty space. So that is the function of memory management. Next is about file management. Now what is a file? A file is a collection of related information defined by its creator. Commonly file represents both source and object forms and data. So generally for every file there is a name of the file. The operating system is responsible for the following activities in connection with file management. So if you consider Windows or Linux operating system, you can just right click and create a file. You can just select the file, you can delete the file. So that is one operation. You can the similar operation can be done on directory creation and deletion. Also it supports primitives for manipulating files and directories. What are these primitives? For example, I want to search for a text in a file, so that can be done. If you want to move the file pointer from the beginning to the end of the file, that is also possible. If you want to know who is the creator of the file, what permission has been set for the file, read, write, execute. So these are some of the primitives. Next, mapping of the files onto the secondary storage. Now the files are stored in the secondary storage by the file name. So whenever we want to look for a file, or when we double click on a file, the file is actually stored in a scattered manner in the hard disk. So those mapping is also handled by the file management module of the operating system. So these are also the functions of operating system. Also backup of the file on the stable storage. Now the hard disk is considered as a stable storage here. So this is about file management. Let us go to the input output system management. So the input output system consists of a buffer caching system, a general device driver interface, driver for specific hardware devices. So if we look at this particular diagram, we see that at the bottom is the device, for example printer or your camera or the CD-ROM, and we see that all these are not directly connected to the operating system. They are connected through controller, printer controller, which is a different device, camcorder controller, which is again a different one, CD-ROM controller, and above it is the drivers, printer driver, camcorder driver, and CD-ROM driver. Then these are connected with the operating system, and the operating system actually handles the application program at the top, which is being used by the user. Now what is this buffer caching system? The buffer caching system is a part in the controller. So let us look at how does this work. So considering the same example, the input devices and the CPU can execute concurrently. This we have already seen in case of multiprogramming. Each device controller is in charge of a particular device type. As we have seen, printer controller in charge of printer. Each device controller has a local buffer. So the device controller, in this case printer controller, will be having a buffer. Now why this local buffer? Communication between the CPU and the printer is matched. Printer is a very slow device, whereas CPU is a very fast device. To avoid that mismatch, there is a buffer, so that CPU will be storing the information in the buffer, and from the buffer it goes to the printer, so that the speed mismatch between the printer and the CPU is resolved. Now the CPU moves data. The CPU will move the data from the main memory to the buffer. Now suppose the user wants to print something, so the application program what he is using, for example notepad, he will give the print command. So the data or the text that is there in the notepad will be sent to the operating system, then to the printer driver, and then to the buffer. Or it can go from the other way also, from the device to the buffer which is in the controller, then to the driver, then the operating system, then to the application using that. And this is how input output system management works, and this is also one of the functionality of operating system. Also, it must be noted that the device controller informs CPU that it has finished its operation by causing an interrupt. So once the printing is done, it will interrupt. The controller will interrupt through the driver to the operating system, informing that the printing is done. Next, let us go to secondary storage management. Now, secondary storage is the hard disk, which is a non-volatile memory, and the major task of your secondary storage are free space management. That is, the operating system is responsible for managing the free space on the disk. So if we look at this particular example, this is the disk and we have many blocks in the disk, so the files are stored in the disk. So the rectangular boxes shows that this is a block. So 0, 1, 4, 6, 8, 10, 11, 13, 14, these are some of the free blocks, as these are marked in white. So the operating system's role is to see which are the free blocks in the disk, so that when a new file comes in or the operating system needs to store a new file, these free blocks can be used to store the file. And the files must not be stored in a contiguous manner, they can be stored in random order. So you can see that this is one of the tasks of operating system. Coming to the second one is about storage allocation. Now we see that there are three files A, B and C, and they are stored in the disk. So you can see file A, the gray color rectangular blocks starting with 3, as it can has been mentioned, starting block is 3 and last block is 22. So there is a pointer from each block pointing to the next block. So 3, 9, 12, 16 and ending in 22. After that there are no more pointer, or the pointer points to null, so that it is identified that the file ends at this particular block. So you can see random blocks are used to store the file 3, 9, 12, 16 and 22. Similarly, if you see file B, 18 to 20, where is, so we can see file B 18, block 18, then 24, 28, 32, 26, 20, and similarly file C 5, 7, starting with 5 to 7. So this is how the storage is allocated. So there are several methods by which storage is allocated from the free spaces. So this is also handled by the operating system disk management module. Last one is disk scheduling. So let us look at one more example. So for disk scheduling, you can see that there are certain numbers 98, 183, 37, 122, 14, 124, 65, 67. So we can understand that there is a file which we want to access, and this particular file is stored in the cylinder 98 till cylinder 67, and we want to access the file. Because they are not in a serial order, if we have to access the file, we have to see that the disk read write head moves from one direction to another. So there are certain scheduling algorithm, disk scheduling algorithm, so that the disk arm moves from one cylinder to another cylinder to another in such a way that the distance traveled by the read write head is minimum. This is one way. If we see the another diagram, we see that it can also be done like this: 53, then 37, then 14, then 0, and then going to the other direction: 67, 65, 67, 98, 122, 124, and then 183. So you can see there are two different ways in which the cylinder can be accessed, one using this way, another one using this way. So there are two scheduling algorithms which can be used to retrieve the file contents from each of the cylinder. So that is also handled by the disk management module of the operating system. So this is also one of the functionality. So that's all for now. We'll discuss the rest of the functions of operating system in the next video.